Alright, today I'm going to teach you how to analyze functions.
Okay.
We read a graph from left to right, correct?
Yeah.
Does everyone understand that? We read a graph left to right. So, what you're going to see, I'm going to draw you an example of a typical graph. Here's a typical graph. That's an example of a cubic function.
Yes.
Okay, let's talk about this.
Correct.
We read a graph from left to right. Right?
Yeah.
Put it away, thank you. Put your phones away. We read a graph from left to right. So, if you were coming from this direction, what are we doing? If we were walking, or let's say this was a roller coaster, what are we doing? We're going up.
The first hill.
We're going up. So this is going up. So we're going to call from negative infinity to whatever this point is going up. It's increasing. At this point right here, it's called a local maximum value. This is a maximum value. From here, we start to do what? Go
Descend,
down.
and then right at that.
And right at this spot,
It's a minimum.
this is called a local minimum. So all the way from here, from this x value to this x value, we're going to say that we are decreasing. Then from this spot, we are going what? Up.
It's a positive cubic.
Okay,
equation.
so let's make up some numbers. Let's say this was -2 and this is 1. Okay.
So the solutions of that.
We would say the maximum value, local maximum value, is -2. The minimum value, local minimum, is 1.
So you're going by the x-axis,
The
not when it's
x-axis,
reaching a
yes.
goal. Okay.
The x-axis. So now, they're going to ask you, what interval is this graph increasing?
Cubically to a third.
It's increasing from negative infinity to what? To -2. And it is increasing from,
-2 to -1.
No.
No, it's wait.
from
Okay.
1 to positive infinity, it is increasing.
So you're only doing the positive trends, you're not counting that -2.
Right now, we're just talking about where it's increasing. It's increasing here, and it is also increasing here. Where is this graph decreasing? From -2 to 1. Now, why am I putting parentheses around the -2 and the 1? What are you doing at this spot and this spot? Are you increasing or are you decreasing? Neither. So that's why we use parentheses. Is that clear?
Yeah.
Now, somewhere in between your max and your min x value, does anyone know what the number is between -2 and 1? 0.5, -0.5. How do you get that? You add these two up and divide by 2. At this point, we call this the inflection point. The inflection point is where the graph changes concavity. At -0.5, and I don't know why I don't need to put it in parentheses, but at -1/2, this graph is changing concavity. So from here to here, this graph is concave down. Does it look like an upside down parabola? Okay. And then from here to positive infinity, it's concave up. So they're going to ask you concave up, concave down. So this would be concave down from concave down would be from negative infinity to -0.5, and it's concave up from -0.5 to positive infinity. what we are doing is we're reading the graph along the x-axis. We're interpreting what the function is doing. Is it going up? Is it going down? Now, the last thing on our list is a constant. A constant would be something that's flat. There is none in this graph because it's very curvy. There's nothing straight. Kind of like when someone dies on TV, what happens to the screen? It goes, goes straight. That would be a constant. Okay, we don't have any of that going, but you will on the back page. So let's start with the first example. Let's see if we can handle this one. So what I want you to do is take your calculator of choice. Hopefully you pick the Inspire, but I can understand if you have the 83 or 84s and you want to do your homework, you want to learn off that, that's fine. So we're not going to save whatever graph is on that screen because that was from the last class. We're going to type in our polynomial x cubed, everyone do that, x raised to the third power. And if you don't have this in front of you, please make sure that you're paying attention. Whoops. Back, I hit enter, and I shouldn't have. Okay. X cubed, x raised to the third power, and then minus 2x, and then minus 5. So once you have that equation typed into your f of x, sure, did we type it right? Yes, we did. Now I'm going to hit enter. Bam, there it is. Can you please sketch this as good of a picture as you can? Can you sketch that on that little graph that I gave you right here? So I want you to interpret this. So it goes like this. It looks like between -1 and -2, this thing is going. It's like right there. Okay, so now, let's talk about this. We need this maximum value. And we need this minimum value. How are you going to find the local maximum and the minimum value? Anyone think they know what to type in? Menu. Analyze graph.
Minimum.
Okay, which one you want to do first?
We'll do, sure.
You want to do minimum first?
Why not?
Okay,
I don't think it matters.
minimum. Whoops. I don't think I hit. Minimum. Okay, now, if you want, you can use that, the middle.
Scrolling, highlight.
Yeah, highlight and then just, it's very touchy though. There you go. Minimum. Why didn't it pop up? There it is. Try it again.
So you're taking the x, so the 1.26.
Menu, analyze graph, min. Oh, you know what? I typed in a different equation.
Yes, you did.
I did. What do you guys have on your paper?
X cubed
What?
minus 2x.
You do. Does everybody have that?
My graph looks like that.
I do that. Actually. Okay, what'd you get for your minimum?
Negative 6.29.
Isn't it the X value?
Yeah, it's the X value. It's the X value.
0.816.
You should get 0.816.
I did the
Why is
Y.
mine not doing that? Analyze graph, min. I'm gonna put my boundary, 0, enter, 2, enter. And there it is. Sorry, it's so low, it's right there, it's 0.816. 0.816, there's your minimum. right there, 0.816. Now, there's a lot of stuff next to it. I have a hard time grabbing this.
I just have a hard time working with.
There it is, 0.816. That is the X value. This is, right here, this X value is 0.816. I want you to write that down. Let's round to the nearest hundred. What would you say the minimum is?
0.82.
0.82. Okay, let's do the maximum value. So you're gonna find your maximum by hitting menu, analyze graph, max. Now your maximum, it's asking you for a lower bound. I would type in -2 and 0. And there it is, right there. There's your maximum. It's -0.816. It's -0.816
So
right
it's
there.
exactly the same as this one.
This one happens to be, is it gonna always work out that way? No. So let's write -0.82. So this maximum, I probably shouldn't have put, let's do this. There's one. So this number is -0.82. That's the X value. So now, let's write, what would you say our graph is increasing from, where to where? Where would you say? Go ahead. Go ahead.
Negative infinity, 0.8, -0.8.
Go ahead.
Parentheses, negative infinity, comma, negative 0.82, parentheses, union, parentheses, 0.82, comma.
Perfect. That's where it's increasing. I'm gonna use a highlighter here and show you where it's increasing. Because how do I know it's increasing? We don't read a graph this way, we go this way. So this is where it's increasing, from here to here. So from this X value all the way there, our graph is increasing, and from here, it is also increasing. What is it doing between -0.82 and 0.82? What is it doing? It's decreasing. So that's our interval where it's decreasing. Our inflection point is the number right in between, and I didn't draw my graph very well, but it should be right in the middle. What is the halfway number? What's the X halfway number between here and here? It's 0. Is it gonna always work out that way? No.
Can you switch out paper over so I can see the end of the thing after reading?
This?
Yeah, thank you.
So, how do you get the inflection point? It's, you add these two up and divide by 2. Well, they're gonna cancel each other out. When you divide 0 by 2, you get 0. So this graph is concave up from 0 to infinity. And it's concave down from negative infinity to 0. And where are the constants? There are none.
So how do you do concave up? Like, I get it that it's two parabolas.
Here's the inflection point. So this is concave down.
So it's from the
from-
inflection point?
Yes,
Okay.
it's from negative infinity to this inflection point,
Okay.
which is 0, even though my graph doesn't look like it's right in the middle.
Okay.
And then from 0 to positive infinity, it's concave up.
Got it.
All right, let's try another example. Example 5. Type this in your calculator. Everybody should have a calculator. Even if you don't have these notes in front of you, you should type this in. We are not saving, we're adding a new graph. You're gonna type in -2x cubed. And hopefully you remember some of the characteristics of, remember when we did polynomials last year? And the behavior, the end behavior, and how many curves? We did all that last year. Okay, so here's my graph. Sketch this the best you can. This will help you. It looks something like this. So, what's this gonna be called? Minimum. Let's find it. Let's find that local minimum. What do I hit? Menu, analyze graph, min, and it looks like it's between,
0 and 1.
did you get .087? .087 is your minimum. Let's round to .09. .087 or .09. So where's our maximum value? Can anyone tell me what the maximum value is?
1.91.
It's 1.91. Okay, so let's interpret this graph now. So 0.09 is our min, our x value. It's real close to 0. Our maximum value is 1.91, kind of close to 2. So let's read this graph. From negative infinity to 0.09, what's our graph doing? What are we doing? We're decreasing. We're decreasing. So interval decreasing, negative infinity to 0.09. Where else is it decreasing? From 1.91 to infinity. Where is it going up? 0.09 to 1.91. Now, how do you find the inflection point? It's the halfway number between here. So halfway between 0.09 and 1.91, if you took these two numbers and added them together and divided by 2, what do you get? You should get 1. So 1, the number 1 is your inflection point. So this is concave up. It's concave up from negative infinity to 1, and it's concave down from 1 to positive infinity. And there are no constants. Okay? So for homework, I'm going to have you do these graphs. Now on these absolute value ones, you will see a constant. You will see a constant. Now I want you to flip it over to the very back where it says 29. Do some story problems. It says a rectangle has a perimeter of 100 inches. So let's draw a rectangle. And it says that the one side has a length of x. And we have a perimeter of 100. So can someone, using this information, give me an equation for this perimeter? Go ahead. Yep, I said it perfect. 2x plus 2y equals 100. That's what they just gave us. If the perimeter of this rectangle is 100 and one side has length x, the other side is y, we're going to say. This is the formula for perimeter. But what's the formula for area? Area would be, we're going to use x and y. Area is equal to x times y, right? We don't know what the area of this is, but we want to express the area of this rectangle as a function of x. So what you're going to do is you're going to solve this equation for y. How would you solve this for y?
Subtract 2x.
Subtract 2x.
And divide by
and then divide by 2. Thank you, Nick. So what's y equal to? 50 minus x. We're going to plug this into this equation. So the area is equal to x times 50 minus x. So what we did was we expressed the area of this as a function of the perimeter.
Never mind.
Now, what you're gonna do, so that's this answer. A is express, so this is the area formula using this perimeter. That's it. Area is equal to x times 50 minus x. You're plugging one into the other. Now, look at B. B says, use this function to find the dimensions of of this rectangle that has a perimeter of 100 inches in the largest possible area. So if you graph this function, so go to your calculator and you're going to type in you're going to type in 50 or x times 50 minus x.
It's 30.
Now you may have to write it out. Did anyone try typing it as 50x minus x squared? For some reason, I don't know why. Okay, now, do you see something weird? It looks like almost like a line. You're gonna zoom out. Window, zoom out. Keep hitting that until you see, you'll start to see it. What you have here, I think one more time, there it is. I'm gonna blow this up for you. This is what it is. It's an upside down parabola. And what all of these ordered pairs are possible dimensions of this rectangle. Well, if we want to maximize the area, because this is the area formula, if we want to maximize the area with having 100 as the perimeter, we want this x value. Unfortunately, it's somewhere between 0 and 100. Because of my scale, my drawing, I had to zoom in or zoom out. So I need this maximum. I want to maximize my area. All of these are possible dimensions, but this is going to give us the largest area because I typed in the area of this. So now, what would x have to be in this problem? This is your picture. Looks like this. I want to know what this is. This x value is going to give me this x value here, and then I can figure out what y is. So if you were to type menu, analyze graph, menu, analyze graph, and we're going to look for the maximum because we're trying to maximize, and you type in, some of you guys do this, and you maximize it, what do you get? You get 25. Right there. It's right, see where that finger is? 25 is your x value. This is the ordered pair, but we don't want that value. We just want the x value. X is 25. So, let's see if this makes sense to you. If you were to plug 25 in here, we want to find the dimensions of this rectangle. We want to maximize the area. What would this be if I put 25 in here? What's 50 minus 25? 25. So see if this makes sense to you. We would have a 25 by 25 rectangle. It's actually a square, right? So if this were 25 by 25, is our perimeter 100?
Yes.
And only if you have 25 is the length of the sides, you're gonna get the biggest area of this rectangle. Now, does that mean those are the only dimensions of this rectangle? No. You can get 100 with different numbers, right? But to get the biggest area, if the dimensions of this rectangle are 25 by 25, you have the largest, you've maximized your area. Does that make sense? So what you're doing on these story problems is you're going to, like for this one, a rectangle has an area of 240 inches squared on one side. They want you to write an equation for the perimeter. So for this one, I'll start you off. Anyone think they know how to, what's the formula for area? Area is equal to x times y. And we have the area of 240. We want to solve this for y. And then you're going to plug this. We want to express the perimeter of this rectangle as a function of x. So the perimeter is going to be 2x plus 2y. You're going to plug this now in for y right here. So you have perimeter is equal to 2x plus 2 times 240 over x. Now type this in your calculator, this formula right here. And what you're going to do, you want the smallest possible perimeter. So what do you think your graph is going to look like? Did you type it yet? Jeremy, did you type it in? I think you get something like this for that, if I recall. Did anyone get that yet? Keep hitting zoom out. Anyone have it yet? You have to zoom out. Yeah, you got it right there. Okay, so he got it. Menu. You get these two parabolas. Well, they're not really parabolas, I don't know what you want to call them. But you want this minimum. Why do I want a minimum? Because they're asking you for minimum, the smallest possible perimeter. Now, so you want this x value right here. Why am I going to disregard this? You don't want negative dimensions of a rectangle. So how do you get this smallest possible dimension? You're going to hit Analyze Graph. Go ahead, do that for me. Menu, Analyze Graph. I want the minimum. Can someone tell me what the minimum is? I think you get 15.5. Is that what you got? 15.5? And then plug 15.5 in here. What's 240 divided by 15.5? And you get 15.5. So to have the smallest possible perimeter, if your rectangle was 15.5 by 15.5, you would get the smallest possible perimeter. So I want you to try the rest of these for homework. And we will do the greatest integer on Monday. That's it.